to us are called X and Y intercepts. And hopefully that rings a bell to you. Okay? And we're going to talk about just the definition of what it is anyway, in case you forgot, and then we're actually going to work with them. Okay, so, well, let's see if we can fill in the blank. A relation is a connection between two quantities, what we just talked about. A relation can be represented graphically by a set of ordered pairs. So if you have two pieces of information, you can connect them with an ordered pair. That can go on a graph. Just kind of collects your data nicely. The first component of a set of the ordered pair is the x-coordinate, also known as the input, right? So yesterday we talked a lot about how x is the input. It's also the independent variable. Values of the input are values of the, independent variable. So that's what we learned yesterday, right? Typically our x is the first thing in an ordered pair. It's our input. Input means independent variable as well. Those are all just some basic definitions. The other coordinate on an ordered pair is the y-coordinate. So the second one in an ordered pair is y. The y is known as the output, or like the vertical one on a graph. Right? And the output is known as the dependent variable. That's just a review of some definitions, stuff we did yesterday, right? Nothing too exciting. All right, let's get into X and Y intercepts. So let's look at these graphs. We have three graphs here. We're going to list the x-intercepts of these graphs. Right, before we can list the x-intercepts, we need to know what an x-intercept is. Right, an x-intercept is where your graph crosses the x-axis. The x-axis being the horizontal axis, right there. Right, that's the x-axis. So if you're looking for the x-intercept, you're looking for where you cross that line, that x-axis, the purple one I just colored there. Looking at this graph, we can visually see our x-intercept is right there. That is the spot that my graph or my line crosses the x-axis. That spot is at -3. As an ordered pair, we would say it's at -3, 0. At that point is 3 to the left. It has not moved up or down. So it's -3, 0. Some graphs have more than one x-intercept. So if you look at the second graph and we're looking for the x-intercept, you're looking for where your graph crosses this purple line. And you'll notice your graph crosses in two places. It crosses once right here and once right there. So this one actually has two x-intercepts. The first one is at -2, 0. Right? It hasn't moved up or down. So as an ordered pair, we call it -2, 0. The second point is at 3, 0. X value of 3, it's 3 to the right. It hasn't moved up or down. It's at 0. Try the very last one on your own. So see if you can write the ordered pairs for the x-intercepts of that circular graph. So I've drawn my x-axis, the purple line, right, the side-to-side line at the start. And I've labeled the 2 points, the 2 yellow dots. Those are my x-intercepts because that's where it crosses the purple line. The first one looks like it's at 1, 2, 3, -4, because it's on 4 to the left. And it hasn't gone up or down, so it's 0. The second one is at 1, 2, 3, positive 4. And again, it hasn't gone up or down, but it's positive 4, comma 0. Those should have been your 2 x-intercepts for that circular graph. Awesome. We have 5 x-intercepts written out there. Look at those 5 x-intercepts. And what do you notice that they all have in common? Yeah, they all have a 0 as the y. Right? They all have that. And that's not a coincidence, because if you're crossing the x-axis, it means that you never went up or down. Right? You stayed flat. You just moved left and right. So this idea that the y value will always be 0 is a rule for x-intercepts. Right? That'll work for all x-intercepts. That's what we're going to put right in that box. What do all these points have in common? All x-intercepts, and I write x-intercepts like this, x dash int. All x-intercepts have y equal 0. They all have an output of 0. They all have a y value of 0. Awesome. Let's go back to those graphs and let's see if we can find the y-intercepts of those things. So if you're looking at the first one, y-intercept is where you're crossing the y-axis. The y-axis is this blue line right here. Right? It's your up-down line, your vertical line. That creates your Cartesian plane. You're trying to figure out where your graph crosses the blue line now. It crosses right here. We would say that crosses at 5, but the y value is 5. The x value in this case is 0, right? Because I never moved left or right, I just went straight up to 5 to get to that point. So I would say it crosses at 0, 5. I'll do the next one with you. Let's see if this works. It's not so bad. So you're looking for the y-intercept of this second graph. Y-intercepts have to cross the y-axis. The y-axis is the vertical axis, the up or down. Looking at that thing, we can figure out that the y-axis is crossed right there. That's at 1, 2, 3, 4, 5, 6. The x value is 0 because I never moved left or right. I just went straight up to 6. So it's at 0, 6. For the next graph, for the circle, there's 2 y-intercepts. I want you to try to find both of them and then write out the ordered pair for both of those y-intercepts on that circular graph. Awesome. So you look at the circular graph, you're looking for the y-axis. I've drawn it in blue. It crosses at 2 points, those 2 yellow dots that I put on for you. It crosses at 4 and -4. We would write those points as 0, 4, 0, -4. The reason it's 0 is because it didn't move left or right. And if you look at these points, and you realize they're all y-intercepts, you'll notice a trend with these ones as well. The trend with these ones is that all the x values equal 0. And that's not a coincidence either. Right? Y-intercepts mean that you've never moved left or right. So you've always stayed at x equals 0 and then just moved straight up or down. Okay? That's our next rule. So our first rule is that x-intercepts have a y value of 0. Y-intercepts have an x value of 0. I'm going to say all y-intercepts. So those two answers are probably the important part of right now. Right here. That's that. Understanding that x-intercepts have y equals 0, y-intercepts have x equals 0. Because that's going to help us mathematically in the future, that piece of information, those little facts. This is just kind of like, I don't know, a bunch of words that you could read through one day if you wanted to. What we're going to do instead is we're just going to jump down here to class example 1. And we're going to try to find x and y intercepts without a graph. With a graph, it's really easy, right? You just look at it, you point at it, you write out the point. It's not so bad. Mathematically or algebraically, with an equation, it's a little more challenging. All right, so this question says, the equation of graph 1 on the previous page is, and they give you this equation. Algebraically, so algebraically means like writing out your work mathematically, right? You're going to move things around, calculate things. Algebraically determine the values of the x-intercept and y-intercept. And then they've made a little grid for you so that you can do your x-intercept work right here, your y-intercept work right there. Awesome. Let's start with x-intercept. We don't have a picture now. All we have is this blue equation. If you want to find the x-intercept, what do you know about all x-intercepts? They have a y value of 0. If they have a y value of 0, then you can go to this equation and you can change y to be 0. And what you'll be left with is just the letter x, your input value. And you'll be able to algebraically figure out what x must be for y to equal 0. And I'll show you how to do that. All right? But the key concept here is looking for an x-intercept, y equals 0. So go to your equation and make y equal 0. When I make y equal 0, that's how I do it. So I've changed it to purple so it stands out a little bit. Like that. If I'm changing a letter to be something, I completely change the letter, I replace it with brackets, and then the number. All right, that's how I do that. After I replace a letter, I do any calculations that I can now that I know that number. The calculation I can do on this one is 3 times 0. 3 times 0 would equal 0. The 5x plus 15, I can't do anything with that yet. All I'm doing is calculating where I did my substitution. Everyone's okay with that? Awesome. All right, we algebraically have to figure out what x is. That means you want to get x by itself. All right, that's how I'll always refer to it. Get x by itself. You might hear the term isolate x. Same thing. Get x by itself. Get it on one side of the equal sign all alone. The way I like to tackle it is to move everything away from it. Okay, so I'm going to look at this thing, and I'm going to realize that currently there's a 5 and a 15 that are on the same side of the equal sign as x. And I need to move those things away. The way we move them is by using reverse operations, right? Opposite operations. You've hopefully heard of the term bedmass. So I write that on bedmass. Bedmass is the order in which you should perform mathematical operations. So when you're calculating things, you should do brackets first, then exponents, then division, then multiplying, then addition, then subtraction, right? That's what bedmass means. You guys have heard that before, right? Yeah, maybe pedmass. Anyone ever done pedmass? Yeah, a couple people. Just depends on who your teacher was, right? It's the exact same thing. When you're getting a letter by itself, you move the numbers in reverse order. Okay, so if I'm looking at this, I would say, are there any subtractions that I need to move? And if I look at this, there's no subtractions. Then I say, are there any additions next to my x that I need to move? There is, right? I have a plus 15. So I need to move the plus 15 to the other side first. We move it by using opposite operations. So instead of plus 15, I'm going to subtract 15. What you do to one side, you do to the other side. So if I'm subtracting 15 from here, I'm also going to subtract 15 from this. Math is like a balancing act, right? So anytime you do something, there should be some sort of balance to it. I subtract 15 over here, I balance it by moving 15 over here. On the right side, 15 minus 15 will cancel out, so we put a line through it. That's what got rid of it. On this side, 0 minus 15 equals negative 15. And now I have negative 15 equals 5x. Awesome. My goal is to get x by itself. I'm working through BEDMAS in reverse to do that. I now have to check to see, is there any multiplication next to my x? There is, right? When you have something like this, 5x, that means 5 times x. So I need to get rid of my multiplications. To get rid of my multiplication, I do the opposite operation. The opposite of multiply is divide. So I'm going to divide both sides by 5. So I put a little division symbol or a little fraction, and I go 5 underneath it. That means divide by 5. Again, what you do to one side, you do to the other. On the right side, our 5's cancel out. On the left side, you need to calculate negative 15 divided by 5. When you put that in your calculator, you're going to end up with negative 3. And on the right side, all you have left is x. You've now figured out where your x-intercept is. Because when y equals 0, x equals negative 3. My x-intercept is at negative 3, 0. You guys did some of that last year, hopefully? Ring a little bit of a bell? Good. Okay. That's just the x-intercept for that equation. Now we want to try to find the y-intercept of that equation. To find the y-intercept of an equation, so get rid of these purple lines. Perfect. To find the y-intercept of an equation, what do we have to know about all y-intercepts? 0, right? X equals 0. That's perfect. So if I know that I'm looking for a y-intercept, I also know that x equals 0. I can then put that into my equation. When I substitute that into my equation, I change all my x values to be 0. When I change it to be 0, I use brackets. Like this. Awesome. After I do my substitution, there's no x's left, which is wonderful. Then I do any calculations I can now do, right? Because I just changed the letter to a number, so there's probably some calculations I can do. In this case, there's a couple. So I'm going to do this calculation first. I'm going to figure out what 5 times 0 is. 5 times 0 is 0. So I have 3y equals 0 plus 15. I now have another calculation I could make. I could figure out what 0 plus 15 equals. Wait, there's no letters there, that's just numbers. 0 plus 15 is 15. So now I have 3y equals 15. I've done all my calculations that I can. Fantastic. The goal here was to figure out the y-intercept. To figure out the y-intercept means you get y by itself, right? You isolate it. To do that, you have to do reverse bed mass, right? Move numbers away in the opposite order of bed mass. So the first thing I do is I look at my y and I move any subtractions there might be. There's no subtractions to move. Then I move any additions there might be. There's no additions to move. Then I move any multiplications there might be. There is a multiplication next to my y. Right? I have 3y, that means 3 times y. The opposite of times is divide. So I divide both sides by 3. What you do to one side, you do to the other. On the left-hand side, the 3's canceled out. So I'm left with just y. 15 divided by 3 equals 5. That means my y-intercept is at 0, 5. English is about the algebra, substitution, where some numbers came from. I try my best to color code my algebra so that it's kind of easy to follow. Usually purple, in this case, meant I was moving something, or balancing something. Blue is what I ended up with. Okay, let's try it again. We got question 2 here. We're going to try to calculate the x and y intercepts. They gave us an equation. The equation's a little different. It's this guy right here. Right? If we want to find the x-intercept, we'll start with that. We know x-intercepts have a y value of 0. So I go to my equation, I change y to be 0. X squared plus bracket 0 bracket and then squared equals 16. Like that. Okay, that's how that substitution should look. The letter y changed, nothing else. The square is still there, everything else is still there. Just the y changed. After you do a substitution, you calculate whatever you can. In this case, it says calc, even though it's old. You calculate 0 squared. 0 squared is 0. Now, realistically, you don't have to write that. Right? Like if you're writing plus 0, anything's plus 0. You don't actually have to write that. So all you're left with is x squared equals 16. Like that. Awesome. Your job is to get x by itself. Yeah. That's exactly what it means. Yeah. So to get x by itself, you need to get rid of the square. To get rid of the square, you square root. I should have done that purple. Square rooting cancels out the square, and it leaves you with x equals 4. Now, technically speaking, it actually gives you 2 answers. Okay, so the other answer is -4, which we don't really do a lot of. I'll explain it really quickly. You don't have to stress about it too much. The reason it gives you -4 as well is in the past, you've always used something called the natural root, which meant the positive version when you square root something. Technically, there's a positive and a negative version anytime you square root something. The reason being is if I put -4 in for x, -4 squared would turn into positive 16, right? Because a negative times a negative is a positive. So anytime you have this square situation and you square root both sides, you technically get a positive and a -4. Now, you're not really going to be tested on that. I wouldn't freak out too much about it, but that is the technical correct answer. You get 2. I'm only going to look for 4, 0. That's what I'm really wanting you guys to be able to get. Fantastic. I'll give you about a minute to try to find the Y-intercept on your own. Remember, the starting point would be all Y-intercepts have x values equal to 0. Go ahead and give that a shot. Awesome. So my work here is on the board. I went to find my Y-intercept, so I changed x to equal 0. I then wrote out the exact same equation that I had right there. I just changed x to be 0. I did it with brackets. I understand at this point the brackets haven't really done much for us, especially in these last 2 examples. But it's a very good habit to use brackets when you substitute things. Okay, so try to get into that habit. It'll help out and pay off in the future. After I substitute, I do any calculations I can. 0 squared equals 0, which means it basically does nothing. Okay, so that's why it disappears, because 0 plus y squared is still just y squared. I then had y squared equals 16. I wanted to get y by itself, so I had to get rid of that square somehow. To get rid of that square, that little 2, I had to square root both sides. And that left me with y equals the square root of 16, which is just 4. That meant my y-intercept was at 0, 4. Fantastic. We're going to break this lesson up into questions. We're basically taking everything we've talked about so far this unit and putting it all into one little example. And we're also going to interpret a graph a little bit, because now that we know what x and y intercepts are, we can interpret x and y intercepts. So this question talks about Lisa purchasing a car. So Lisa purchases a new car for $20,000. The value of the car can be represented by the formula, and they give us this nice little formula. Okay. Where V is the value of the car in dollars and T is the age of the car in years. Just looking at this equation, most of our equations have x's and y's, and our graphs almost always we talk about them as x's and y's, right? Where x is the input and y is the output. Looking at this, which one of these values would be the input? Remember the input being x, or the one that has the numbers all around it? T, right? T would be the input. So on a graph, that means T equals x. That also means that V equals y. Right? So when you're graphing it and you're talking about that kind of a comparison, and we do that a lot once we start using our graphing calculators, we need to understand which one of these letters is x and which one of these letters is y, because they're using V and T, and we're used to x and y. Awesome. It then says complete the table of values. Here's the table of values. And plot the ordered pairs. When we're given a table of values, what they do is they give you a whole bunch of input values. We learned yesterday that you take those input values, you put them into your equation, you calculate your output value. I'll do one with you, and then we'll fill in the rest really quick. So if you look at the equation, my input, or my T, equals 0. I go to my equation, B equals 20,000 minus 1,250 times the input of 0. Put this thing into your calculator, and you'll figure out what your output value is. It happens to be $20,000. It sounds like stuff we did yesterday. We took inputs, we put them into an equation, we got outputs. In our case, when an input is 0, the output is 20,000. That means we have an ordered pair and it's 0, 20,000. You should do that 3 more times. Okay, so you're going to input the number 2, input the number 4, input the number 6. I'm going to show you what those answers are. So if I inputted 2, I should have got 17,500. If I input the number 4, I should have got 15,000 as my output. If I input the number 6, I should have got 12,500. And those would have been my 3 output values for those inputs. The ordered pairs, you then write them X, Y, input first, output second. And this would be 2, 17,500. This would be 4, 15,000. And this would be 6, 12,000. Those are my 4 ordered pairs given those 4 inputs. Awesome. That's straight out of yesterday. We then want to take that info and take the ordered pairs and put it on a graph because it's easier to interpret a graph. It also allows us to connect the lines and then use our graph for more information. So we have 0, 20,000. Let's plot that one first. 0, looking at this massive chart, so this is going to be a bit of a problem. I might just downsize this. Give me a second. That'll work. Oh, it's a little bit off still. Maybe a little hard to see, but that's okay. Here's our graph. My first point is at 0, 20,000. That means I don't move left or right, and I go straight up to 20,000, and I make a point. Awesome. My second ordered pair is at 2, 17,500. So I go to the right 2, and I go up to 17,500 right there. Halfway between 17,000 and 18,000. And then plot the next one, which is 4, 15,000. And the next one, which is at 6, 12,500. And I end up with those 4 points. You should hopefully notice there's a bit of a trend. Okay? It's easier to see that trend if you draw a line connecting those dots. Remember that your line has to be perfectly straight and has to go through all 4 of those dots perfectly. If you do that, I'm just going to do a couple more dots. So it helps me. So I can connect these dots and draw a perfectly straight line. Hopefully you are doing the same thing and drawing a straight line, connecting these dots. Whoa! That was a harder one. See if I can do it. No, give it one more shot. B. As straight as I'm going to get on that big a board. Hopefully yours is like perfectly straight. Again, using like the back of your calculator, it's a great way to write a straight line. Especially the other calculators, like the little battery pack thing, it pops right off. It's like a perfect straight line and always fits your page. If you want to bring a ruler, that's fine too. Or bring whatever. Whatever's a flat edge for you. Debit cards work well too. Or licenses. Awesome. Now that we've plotted our points, we've connected our dots, right? And we connected our dots because this was continuous data. right? It means that it gradually happened. My car didn't just all of a sudden become 6 years old, right? It slowly, day by day, got to 6 years old. So this is continuous data, so we connected the dots. Question B. What does the ordered pair 0, 20,000 represent? This is a word problem. All right? Word problems have meaning to it. This isn't just data, this is meaningful data. So when they say 0, 20,000, we need to remember what x is and what y is. For us, x is t and y is b. This means I can interpret this point using t and b instead of x and y. I could say at time 0, the value of the car is 20,000. Time equaling 0 means that's the day she bought the car. So when she bought the car, it was worth $20,000. That's what this point means. When she bought the car, for $20,000. And we could look at any point and we could discuss what it actually means, right? This ordered pair 4, 15,000. That means something. That means after 4 years, the car is $15,000 or worth it. Excuse me. You could look at another point. When the car is 2 years old, it's worth $17,500, right? Every single moment in time on this line is telling you something about the value of the car. It just depends how long it's been. If we look at C, it says use the graph to estimate the T-Intercept. Remember that T was X for us, so they're asking you for the X-Intercept. Looking at this graph, I would estimate that the X-intercept is right there, or the T-intercept, and it's at 16. Looks like it's at 16 to me. Is that on your page? Go to 16? Fantastic. So use the graph to estimate the T-intercept. I've estimated it at 16. I'm going to say it's at 16, 0. What does the T-intercept represent? What does it mean? 16 is time, 0 is value. This means after 16 years, my car is worth $0. It's no longer worth anything. That's what the T-intercept is telling me. It's telling me when my car is worthless, essentially. I'm going to just say after 16 years, the car has no value. So the X and the Y-intercept, they actually meant something, right? And they actually told us something useful. Told us how much it was worth when you bought it, how long it's going to last for. Approximately 16 years. And of course, this is just like a modeling thing, right? Like this is just a best estimation. It's obviously not perfect for real life situations because there's so much that goes into a car. But it's a good ballpark. Part D, use the graph to estimate the value of the car after 3 years, 10 years, 14 years. They've given you 3 different inputs, 3 different X values. You need to try to estimate the Y values, or the value. Looking at this chart, the way I would do that, I would look to figure out where 3 years is. 3 years is right here. Now that I know my input is 3, I'm going to figure out what my output is. So I'm going to go up until I hit the line. It hits the line about here. Maybe it's a little bit below that perfect marker, right? But I'm going to estimate that at 3 years, the value of the car is 16,500. Give or take. I think if your line's better than mine, it's actually a little bit below the 500. Right? My guess is if you had like a perfect line with a ruler, it's probably closer to 16,250. Yeah? So it's just an estimate, right? That's all these graphs can really do for us when we draw by hand, is we can estimate. After 3 years, I'm going to say 16,000. Let's go with 250 because I got a lot of nods when I said that. Beautiful. I want you to try 10 years and 14 years on your own. So try to write the value of the car after 10 years, the value of the car after 14 years.